Hello everyone, welcome to KaliIO community. And today is our second session. We are starting from our second session. So, welcome everyone. I will give briefly introduction about our KaliIO community. Yeah. So, KaliIO community is we have created this community for entrepreneurs, technology experts, and mainly for students from various technology domains to learn and grow and innovate the things to communicate with each other. Our community is designed to be the knowledge and the sharing hub with each other. We have provide the networking and skill development things that we are going for today, and we are connecting the student with each other with expert peoples and like-minded peoples, so everyone can share their knowledge. Yeah. Um the KaliIO is a small startup based for the software and web development things. We work for the mainly for startups and small businesses, for individual professionals, for creating their custom softwares and managing their social media. Our vision and mission is is simple: to connect the student and upcoming entrepreneurs from students with the field experts to explore new opportunities in the respected domains. Our objectives are providing the platforms to the student and student entrepreneurs for networking with expert, exploring the new and upcoming opportunities. So our today's session is our today's session is for discovering the Python's linear regression, like cleaning the data, spot issues, and making informed decisions. So the outline that is the we are going to look out the linear regression implementation using Python and basic data cleaning approaches to identify the issues. And our today's speaker was Omkar Nandan Choudhary. So is an electronics engineer, studied from Thakur College of Engineering, Mumbai, and currently pursuing MBA from IIM Bodh Gaya. So, welcome Omkar, and over to you. You can start.
Yeah, thank you.
Yeah.
I hope my screen is visible. Hello.
Hello. Yeah, your screen is visible.
All right. So, first, I'd like to begin with two concepts, right? And hold on. Yeah. So, this first is correlation, and other is causation. And understanding the difference between these two is very important when it comes to data science. Causal relation. Okay. Now, correlation is seen uh, uh, in a lot of fields and almost everywhere. So basically, if there you see a graph, right, what correlation will do is that it will show you the two data. Let's say this is x. Hold on, let me. This is x. Similarly, if this is y, and both of them move together, there are different or lots of points here. Both are moving together. What we see is this is correlation. So it is not that x is affecting y, it's just that both of them are moving together in time. Let either they are increasing or they are decreasing, right? So this you can see in stock market. So if the entire market is bullish, that the entire market is increasing, the share price of different companies will also increase. Similarly, if the entire market has a negative perception towards it, the share price of each and every
Hello.
company will decrease. Hello.
Hello, Omkar. Yes.
Yeah.
Actually, there was a voices coming from your background. Actually, the Aarti was going on, right?
What RC?
Actually, some noise is coming from your side. Um, yeah, yeah, yes, yes. I think the noise stopped.
All right. So understanding the correlation and causal relation is very important. So this happens in stages where when companies make decisions, right? So they see the data, they see that two parameters are moving simultaneously, and they start believing that one of them is affecting the other, and that is not the case. It's just that both of them are moving together, and there is no actual relationship between them. So, for example, let's say the crime rates are dropping, and you see the amount of money that is being invested into the police force is increasing with time. So, some might say that because the amount of money that is being put into the police force is increasing, the crime rate is dropping. The data might say that, but the reason behind this could also be that it's just correlated and both of them are moving together. Not really there is not really a causal relationship, which means that the amount of money which is being put into the police force is not actually causing the drop in crime rate. So when it comes to making decisions, it is important to understand what is the actual cause of the parameter which you're looking for. For example, which we'll see, I'll show you a database where there is we are determining the second hand price of cars. So when you are going to resell that car, you want to understand what would be the price at which the car resells, right? So you need to understand exactly which parameter causes or affects the uh, final price of the car, and which parameters are just moving with it. All right. So there are different statistical tools which help in letting us understand this, and correlation just uh, how we should correlation has often led to big mistakes which policymakers make when they do not understand the actual causal relation there. So there is difference between correlation and causal relation. I just wanted to keep that in mind. Causal relation means when you're looking at the parameter, the result parameter, you need to understand which actual elements or reasons there are which are affecting that parameter, and some of them are just moving with it. They are moving simultaneously and not actually affecting each other. Okay. Now let's come to very basic steps, which is data cleaning. Now, whenever you get data, and this data can be found out from surveys, which companies do often. This data can be through, transaction details, which companies like Paytm or even banks collect. So, when you get that data, you need to clean that data to get appropriate data, which you can then build a model on. Unless and until you clean the data which you have will affect the model negatively and also might reduce the effectiveness of the model or the accuracy of the model. So first of all, you need to remove duplicate data, and duplicate data in most of the times it's because that uh, there are old generation data. For example, when you update your Windows, there is also the version of the previous update which is still stored. So this happens often with databases, and they just keep on adding new transactions, but also the old transactions are there which now become irrelevant. So you need to remove duplicate data or data which is irrelevant to your entire database. So once you remove that data, then you start dealing with outliers. Now this happens, let's say in our case, which will take of second-hand car prices. So for second-hand car prices, there are some cars which might sell for abnormally large amount of money or abnormally low amount of money. So this abnormality, you need to remove that, because that is a random case, and we are not going to consider it in our model to make it as accurate as possible to the majority of the transactions. If there are any doubts here, what I'm trying to say, please unmute yourself and ask. So what we are going to do with is we are going to deal with outliers, right? Now to deal with outliers, there are two tests. The first test is 3 sigma test, and another test is percentile test. So the very simple test, which is a 3 sigma test, I'll explain it to you. So is everyone familiar with the normal curve? Just write it in the chat. Either one works. So let me just explain the normal curve first. Then. What happens that most of the data which is collected in the real world, it follows normality, which means that so the center line represents the mean, and most of the data will most of the data points will stay around the mean. So this is represented by the greater area under the curve, right? So most of the data points which is closer to the mean will stay around this center line, and as you move further away from the center line, you get a lesser and lesser probability of finding such data points. For example, any data point which is found over here, there is a very rare chance of finding it. Similarly, on this point. So what we do is that from the mean, we move 3 standard deviations away. So either on this side or on this side, we create a boundary. And this boundary is of 3 standard deviations away from the mean. And any data point which lies outside of this boundary, so any data point which is here or here, will be excluded from the database. So this is the entire thing is the 3 standard deviation test. The values of the standard deviation can be calculated depending on whatever the distribution is, and that formula is given or even taught to you in your engineering applied mathematics classes, and you'll find that in your textbook or even on a website. Just Google it. Basically, once you find the 3 sigma value, 3 multiplied by the standard deviation, you'll find out the range at which you can just cut it off. So let's say the standard deviation comes out to be 3 and the mean is 6, right? So the range will be so if the mean is 3 and the standard deviation is 6, so it will come out to be 3 multiplied by 6 comma 3 plus 3 multiplied by 6. I'll again write the formula just for your understanding, which is mean minus 3 multiplied by sigma, which is standard deviation, into mean plus 3 multiplied by sigma. And any value which lies between this interval is accepted. Anything which lies outside of this interval is rejected. And through that, you can deal with the outliers in your database. Then we come with dealing with missing data. Now here there are two cases. First one is that if the missing data has a very low is a very low percentage of the entire database, in that case you substitute the missing data with mean of the remaining data, and if the percentage goes beyond 20%, it is advisable to remove that data. And this is generally done in case of random variables, which means that you have taken the values randomly. But in case you see that if you're, let's say, taking a survey and there are people with weak opinions about a certain thing, and they refuse to give their answers, their opinions on that matter. So if you just remove that data, that means that you have created a bias. The bias in this case being that you have excluded the people who have a very weak opinion about a certain topic, and you just included whatever the opinions are of the people who have a very strong opinion. So this happens in political in surveys of in political topics, because there are generally people in the middle, a large amount of the population which do not have very strong opinions, so they refrain from answering. But the people who have very strong opinions, they answer, and people, which means strong opinions answer, and this happens on both polarities. So for on some topic there are people with very strong political opinions or very uh, like positive political opinions or very negative opinions, and these two people are generally the ones which are heard, and they create a biasness which then we see on the in the result. And the your job, if you are dealing with such data and you are trying to find a very effective solution, or you're trying to find a conclusion which is appropriate, then it is impertinent that you do not get into such biases and you deal with those missing values appropriately. Now this will depend on case to case, and there is no such particular rule which you need to follow to deal with this data, and you need to have to take it case by case, understand what is the data, what kind of people you are dealing with, or what kind of situation it is. But you have to understand, if it is non-random data which you are dealing with, which has missing values, then you cannot just remove it, because that will introduce bias. Fine. Now, once you have done with the entire data cleaning phase, now what you need to do is that you want to understand what there will something which you want to find out, right? So let's first see the data which we have. I'll also share the data. I believe I can share it here, or I'll send it to Prasad, and Prasad will share it with you. So I'll show you the data once. And this here is the data, right? You have the car ID, which is just the serial number 1, 2, 3, 4. You have the brand, the model, the year it was made, the kilometers it has run, the fuel type, transmission, the owner type, whether the person selling the car is the first owner, second owner, third owner, the mileage that it has been through. No, the mileage which is giving, the engine, it basically, I mean, the horsepower or some other stat, the amount of power which it is outputting, the number of seats the car has, and the price which it is selling at. Now the entire thing is that you have this data and you are expecting to predict the price at which it sells, right? So this is your this is what your outcome should be. Now this is a training data. With this you will train and create a model on which you can actually run it and show the predicted price. Now in this case, there are few numerical data. Let's say the mileage, the engine, power, number of seats, kilometer, which can be put into a model and you get a numerical output straight away. But you also have to deal with data which is, for example, first owner, second owner, third owner, and this will very well affect what the final selling price will be, right? So you need to handle these kind of data also. So the way you handle this kind of data is that what you'll do is you will create a dummy variable. For example, here it is owner type, so we'll create a dummy variable which will be owner underscore type underscore first, right? Similarly, owner underscore type underscore second, and similarly owner underscore type underscore third. And all these three variables will be binary variables, which means that whether or not it is true, if it is true, the value will be 1. If it's false, the value will be 0. So if it's true, the value is 1. In this case, for this is 1. In this case, again here 1. In this case, this will be 1. The rest will be 0, 0, 0, 0. Now you don't have to do this manually because Python already has functions which does it for you. But this is the way in which you encode the data. This data, you take the qualitative data and encode it to create into binary variables, which are also called dummy variables, right? Now, when you build a linear regression model, one of the things that linear regression asks you to do is that you do not introduce two data points which are related to each other. For example, if mileage and engine both move together or both are correlated, which means they move together, then you do not introduce both of them, you just take which one is the more relevant data. If you introduce both of them, the accuracy of the model increases, but also does the variability of the error. So the model, when it does fail, it fails it fails like it fails at a greater magnitude than it would have failed in case the model was correctly correctly trained. So what you want is your model to be as close to the mean value as possible, and that only happens if you do not have correlated data into the model. For that, what we do is, if we take just first, second and third, you remove the data which is you remove one of the points. So either first, second, third, it does not matter. You just remove one of them, and these two dummy variables will be introduced into your model. And the same thing will be done with the fuel type, similarly model and brand. Once you have done all this, then you can feed all of this data into a linear regression model, and that will help you find out what is the price. Correct? Let's come to what linear regression is. So linear regression looks something like this. This is a simple linear regression, and it's just a straight line. What actually happens is that you have data like this, but there will also be an error term, u. And the data which you will get look something like this. And what you want is that to create a line which fits through the entire data with making the error as small as possible. Now the error, what the error is, the error is the difference here. Let me show you. Uh, from this point, which is your predicted point, to the actual point, this entire distance, that is your error, and this can be seen everywhere. Similarly, in this case, this is the error. This is the error. So this is all the error here. So what you want is that the line that fits through the entire model, the line which you hope to get out of this linear regression model, it reduces the error to the minimum. And for that, what we do is we train it through the data points. So there are formulas, mathematical formulas for you to get the calculate the value of beta, but we don't really need to do that because with Python you can just fit it into the model, linear regression model, and it gives you the output. So let's walk through that entire thing, how to do it, and if you want to, you can do it yourself on your own computer too. I'm going to start a Jupyter notebook and show you how to do that based on the the entire data car, second-hand car price data which you just saw. Is the scheme visible properly?
Yeah, it is visible.
All right. So for this, because I need to work with data, I'll bring in the pandas library, right? Pandas library gives you the ability to use data frames, and data frames are just Excel tables, but for Python. So if you store data in an array or in a list, it does not gives you the flexibility to either work with it as fluidly as you can work with. Let's say if you store your data in a list, right, you can store different kinds of data, but it does not give you the speed and the accessibility that an array does. But if you store your data in an array, it does not let you store different kinds of data in the same array. It just can be only numerical or only can be what do you say, text data, character based data. So if you want both of them and you want powerful tools to work with it, you use pandas, and in pandas you can create data frames, right? Start models. Okay, formula. So this gives me the ability to use what we say linear regression. The linear regression model, which is already in that in this library, I can use it directly. Now I am going to read that data and just store it in this. So this I will just use PD because that's the name with which I've imported pandas, and then
अच्छा सुनेंगी क्या तुम लेते रहो हमको घुमाते रहो चलते हैं हैं बुलाई ना तब 10 बजे तक तो चारों अल्लाह आज वहाँ से
showing an error because I believe the path is wrong. Yeah, this will work. All right. And we have our entire data model loaded, right? Now, so in this code which you see, the data.head, this method, what it does that it lets you see, visualize the data in a tabular form for the first 5 data entries. You can insert right there instead data.head, let's say 10, and that will also let you visualize the data, but it will give you 10 rows instead of just 5. So it will start with 0, 1, 2, 3, 4, 0 till 9. And it lets you see all the data. Now, the data which I've given here, which we are using here actually, is already clean. There are no missing values, no outliers, any such way. But let's say if you want to see the outlier, right? So let's create a function. So let's define the remove outlier function. We are going to take price. It's just the column name. All right. So now we'll make the first quartile. That quartile will be data, the column name, and we want to make a quantile out of it, which means the first 25 percentile. Similarly, the second, and this will be till the 75th percentile, and we want the inner quantile range, so between these two, so that will just be q2 minus q1, and the data will be the data which remains. So for example, data dot, I'll locate the data which is between these two, for that column which lies between quartile 1, quartile 1, and that gives me my function. I'm going to create a box plot. And I'll make my column as let's say price. So now this gives me the box plot. In this box plot, there are two horizontal black lines, this line and this line. If you see data points which are not here in this case, but if you see data points which are lying around here and here, which means that we have outliers in our entire data, and we need to remove that. For that, what we'll take is we'll take this column name, we'll take the name of the data, which is actually data in our case, and we'll run this function on it. And what it will do is that it will remove all the data which lies outside of this range. So this is the inner quartile range, and what it does that it takes this range, multiplies it by 1.5 times on this side and on this side, and it removes any data points that which lies beyond that. So basically, it removes the outliers. It removes the abnormal values. In our case, we do not have it because the data is already pre-cleaned. But this is just the way in which you can do it. Now, because we do not have missing data per se, we just want to see what a data actually looks like. So for that, we have functions like data.info. Data.info will just give you that it is a pandas data frame. These are the columns. This is the kind of null count, and so basically there are 100 null values and the data type for each and every single value. For example, there are integer 64s, there are objects, again in integer 64, objects, and integer 64. We just have two kinds of data types in our entire database. For checking, if you want to check for missing values, then we have data is null, and because the entire table is filled with false, it shows that we do not have null values. If I actually want to find the sum of null values, even then they can just write dot sum, and that will give you the. Alright, we do not have non-null values because dot sum will give you the count, the exact count. If there were actually null values, instead of 0, you would have 1, 2, or let's say 15. So that would show there are 15 null values, and you'll need to deal with those missing values. In this case, there are no such issues. If you want to drop a few rows, so that is just data dot drop. If you want to drop missing values, just drop NA, and you can just run this. It will give you it will uh, remove the missing values. But again, in our case, there are no such, so we just have 100 rows once again. Now we are going to create dummy values. All right. So we'll create dummy values for brand, for model, for fuel type, transmission, owner type. Yeah, 1, 2, 3, 4, 5. There are five columns for which we want dummy variables, right? So I'll just store them in dummy variables, and what I'll do is that pd dot get underscore dummy variables dummies. Drop first is true. This is to make sure that if we have three dummy variables coming out of each one, then we are removing one of the dummy variables and we get just 2. This deals with multicollinearity, and I'll explain it to what it is after I do this. All right. Mhm. I'll put in all the generic. So this will be brand here. Uh, again, model. fuel type, transmission, owner type. Now we have a dummy variables. If the brand is BMW, false, 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 brand. So the third row, our brand was Ford. So that means for brand Ford column, the value will be true. For rest also it will be false. Again, we can see for the second value, the brand was Honda, Mahindra, Maruti, again, so on, so on, so on. Then for model, fuel type, transmission, owner type. So this is our dummy variables, and we are going to replace the original variables with our dummy variables in the actual data. Right. We'll take the original data and we'll take the concatenate function from now let's see what our data looks like. So we have our original data, all right, but we also have our dummy variables with it. Now, what we'll do is that we'll use this to create a model. So for linear regression, the method for training it, the most popular one is actually ordinary least squared method. Ordinary least squared method. The ordinary actually holds no such significance, but the least squared thing is when we are talking about errors, right? So what we do is we take all the errors and we square each of them, and then we add them, and that value, that sum of the square of errors, sum of square of errors, we try to minimize that value. Once you minimize that value, the line which fits for the model, which corresponds to the least squared value, we take that line as our model, and this that gives us the function of the OLS function which we are going to use it. For example, let's say our model, so model linear regression, let's say model is SM. That was the imported library here. We'll take the SM library and we'll run the OLS on it. Ordinary least squared method. And the formula for it will be price depends on, let's say, kilometers driven. Mileage, engine and power. Mileage, engine, let's say power. These are just the variables which I'm going to use right now. We'll add more to them later. All right. I'm going to close it. Data is data. I'm just going to name the data from where to use, and I'll tell it to fit it for this model. And this gives out us our model, right? Now, the thing to see here is there is something called interpret. So this is the A value which we saw. So the equation would come out to be price is equals to intercept plus minus 4.7692 multiplied by the kilometers driven minus 1.835 into 10 raised to 4 multiplied by the mileage plus 92 multiplied with the engine power and plus almost well, what almost 9991.3172 multiplied by the power, and that would become a model based on which you can actually predict the price at which it would sell, right? But sometimes the value, this value which you get, is incorrect. So you need to actually test for the VIF value, which gives you the multicollinearity of the model. So what the multicollinearity shows is, so let's say your power and engine, these two parameters were moving together. They had correlation between each of them. So introducing both of those data points inside the model introduces error which we do not need. So instead of keeping both of them, what we are going to do, we are going to remove one of them, one of the variables, and that is what and whether or not we need to do that is what is given by the VIF value, right? And the VI value or the variance inflation factor. So this shows multicollinearity. It basically means your independent variables are they correlated or not. Our independent variables in this case being uh, your dependent variable is the price, the independent variable being factors such as kilometer driven, the mileage, engine, and power. All right. And a very simple to do is from stats model stats. We're going to take the model which we had earlier. and this gives you the VIF, right? Here you can see the VIF value is 123, 1, 1, 3 and 3, right? So 123 is for the intercept, and we are going to ignore that. But for rest of the values, the kilometer driven, mileage, engine and power, the VI values is 1, 1 and 3, 3. So as the VI value is less than 10, which means that there is no presence of multi-collinearity, and our the data is appropriate for this model. We are not, we don't need to actually remove or introduce, actually remove any independent variables, and which shows that this model which we have here is valid. And with this you can at to what degree, let's say with a 72% confidence, because this is 0.728, you can with 72% confidence predict the selling price of the car based on the data which you are given, which is just kilometers driven, mileage, engine and power. You can add more such variables because we have more of them, but I'm not going to do now. This just shows the basic of how with Python you can run a linear regression model with very less time, and it can give you a model which you can then run to create predictions, right? Now, where is this useful? So linear regression is one of the most powerful tools for economists. There is a book called Freakonomics by a PhD, like a doctor of economics, and I suggest you read that, in which it shows the very first thing it shows that in the early 2000s or late 1990s in America, the politicians, experts, they were very worried about the increasing crime rate. And the prediction was this crime rate is not going to reduce, it's just going to keep on increasing. But suddenly the crime rate actually reduced. When all the experts were saying that the crime rate will keep on increasing, the crime rate reduced, and they had no explanation for it. But the experts, being experts, they started saying that innovative policing methods, the amount of police, the money which has been put into the police force, these were the factors which actually reduce the crime rate, which was not so because they were just correlated. And an economist, Levitt, he later on published a paper which shows that the reason why the crime rates dropped related to a decision which was made, I think 30 or 20 years back, with in Roe versus Wade, a very famous case which legalized abortion. So that was the actual cause, and this was the relation to it. And this is what is actually this entire data science and again consultancy jobs are all about. What you see is that you see an effect in the real world, and what you want to understand is the causes which are affecting it. Like what are the causes for that effect that you are seeing, and for that you try to collect data. You take that data, you try to build a model with which you can predict, all right, if these are the causes, then you can see this. If these are indicators, then you can expect certain things to happen. And these models help a lot in trying to predict what is going to be the future, but also helps you explain what were the past actions, right? If you have a proper understanding of how to read the data, how to clean data, how to use data, how to build models using it, it can be very helpful for companies, especially when they're trying to enter the market or trying to create new strategies on how to acquire customers, or let's say banks trying to find fraudulent transactions. They can use a logistic regression model which can give them a percentage or percentage of probability of what are the chances of the certain transaction being fraudulent or not. So with data, and certainly, as you know, this is the time where a lot of data is being generated and is available for you to use. You just need to have the tools with you and have a zeal to ask the question why. Just ask any question. Why this happens? Why that happens? And when you keep on asking these questions, and you take your data, take your tools, apply that tools on the data, and find the answers, you will be able to actually find reasons, and also it gives you a direction to go to take decisions, based on data which you know with certainty will be true, and not just based on someone's opinion or some expert's opinion, because at times they also fail. But data will be true, data will stand true, data will not fail. So this is just an introduction to, you know, using linear regression to make decisions based on data. And if there are any questions, I'm open to that. Other than that, uh, I'm done from my side.
So anyone have any question, you can ask freely.
I believe Prasad has already shared my LinkedIn. If you have
Yeah.
any questions even later, you can just ping me there. I'll reply to your messages there.
Yes, I will
So,
share one
yeah,
communities. Okay. So thank you, Omkar, for your great session.
thank you.
I a lot of thanks. Uh, okay, this is great. It's really nice doing.
Yeah, I enjoyed this. Thank you.
Yeah. Oh, yes. So on the behalf of the entire KaliIO community, I would like to extend our great, heartfelt gratitude to Omkar valuable contributions to our today's live session on mastering the linear regression and data analysis. Amazing presentation have enriched our understanding of the subject and the topics that you have covered. We truly appreciate the time and the efforts you have dedicated to our community. Your respective fields and your willingness to impact your wisdom have inspired us. Thank you once again for being a part of our KaliIO community speaker. And thank you once again. So I'm sharing the link and the QR code for the community also and here um, in the meeting. So you can fill out the feedback forms and the certification of participants will be shared over the emails to you. So thank you guys for joining the session and the session was grateful. So you can just fill out the feedback form. Thank you once again. Thank you, Umka.
Thank you.
We will wrap up our session and we will end